Hi, this is Miss Park. In this video, we're going to be completing the square. So completing the square is an algebraic method that I'm going to show you, and its purpose is to find the maximum or minimum of a quadratic. And we know that with a quadratic, it's a parabola, so a maximum happens when the parabola opens downwards, the minimum happens when the parabola opens upwards, and the maximum value is found at the vertex, and the minimum value is also found at the vertex. So if we are given an equation in standard form, like ax squared plus bx plus c, so y equals ax squared plus bx plus c, and we want to find this vertex, then we would like to convert the equation into y equals ax minus h all squared plus k, which is vertex form, and we know that that gives us hk as the vertex. So in completing the square, we always begin with an equation. So let's say, for example, that looks like this. And here is standard form, okay? Ax squared plus bx plus c. And so how would I write this as something with the x minus h all squared? Well, if you look at this one carefully, this is actually a perfect square trinomial. And if you factor it, you get x plus 3 squared. So really, this one is already in vertex form. The a is 1, the h is -3, and the k is 0. So the vertex of this is -3, 0. Okay, so this is already in vertex form. The reason it's in vertex form already is because it's a perfect square trinomial, so I could write it as something squared. Right? Illustrated with an area model, it's basically this. If I fill in the area, so here's my x squared, and here's my 9, and I want it to look like something squared, so that it looks like vertex form, then I want these things to be the same, so I can write it as a binomial squared. I know this is x, I know this is x. The middle term is 6x, which means these two boxes must add up to 6x, but I need these two numbers to be exactly the same so I can write the expression as a binomial squared. So how could I get a number that when you add it to itself, you get 6? Well, that number is just half of 6, which is 3. It means this has to be a 3. This has to be a 3. And then this will be 3x and this will be 3x. And so it's factored as x plus 3 times x plus 3 or x plus 3 squared. Right? So let me try another one. So let's take one that is not a perfect square trinomial. So let's take this one. Okay, we know it's not a perfect square trinomial because the one with the 9 was. So I'm going to fill in my area model again. And I want these two, the dimensions, I want them to be the same so I can write it as something squared. So this will be x and this will be x. Again, I want the middle term to be 6x, so this box and this box must add up to 6x, but they must be the same. So they have to be 3's. So this has to be a 3, this has to be a 3, but this makes a 9. But my equation that I want to complete the square of, or that I want the vertex of, has 11 and not 9, which means I'm going to want x plus 3 times x plus 3 plus another 2. So this can be written as x plus 3 squared plus another 2. Okay. The way we do this without the area model is, I'm going to go back to it here. I do the following. I say, you know, this x squared plus 6x, if only it had a 9 added to it, then I would have a perfect square trinomial. So I'm going to add a fake 9. But you can't just add a number to an expression. It changes the question, right? I'm saying it's equal to the line above. So right now it's not equal to the line above. So I'm going to add this fake 9, but right away subtract the fake 9. So really, essentially, I've added 0. So this line is equal to the line above it. And so now what I do is I say, well, this part over here, the x squared plus 6x plus 9, that is a perfect square trinomial. And that can be written as x plus 3 squared. But then I have minus 9 and plus 11. And if I collect everything, then I have this as x plus 3 squared plus 2. And so is my y equals this. And so now I can see my vertex is negative 3, 2. So you get the same thing with the area model as you do without the area model. Let's do another example. So I'm going to do y equals x squared plus 10x plus 42. Okay, if I did the area model, I'm going to fill them all in. So here's x squared. Now, I need these two to be the same because I want to write it as something squared, like vertex form. So I know this is x and I know this is x. These two boxes have to add up to 10x, but the two numbers have to be the same. So they must be half of 10. So it must be a 5 and a 5. And so here we have our 5x and 5x. And they add up to 10x. Now if I fill in the last box, I get 25. But my expression said 42, not 25. So I've got to make the adjustment. I've got to add the difference. So I've got to add another 17, which means I can write this expression as x plus 5 squared plus 17. Let's do it without the area model. X squared plus 10x. I need to add a fake number. I need to add some kind of number, and I'll take it away again so I don't change the question. But I need to add a number that makes this a perfect square. So how am I going to, what number am I going to use? Right? If you look at the area model, the number that I use is half of the this 10. It's half of the middle term. They have to be the same because we can write it squared. So I'm going to take the number that is half of this middle term, and then to make a perfect square, I'm going to need this to be my last term. So what is this? Well, that's the 5 squared. So how do I figure out what to add? I'm going to take half of the middle term and square it. And that gives me 25. So I'm going to add 25. But you can't just add a number and change the question. So you got to subtract it away again. It's like adding 0. Now, this first part is a perfect square trinomial. Can be written as x plus 5 times x plus 5, or x plus 5 squared. But then I have a minus 25 and a plus 42. And if I put that all together, x plus 5 squared plus 17. Y equals this. This and this become my vertex, negative 5, 17. All right, I'm going to do one more example that's going to be a little bit harder. And it looks like this. Okay, so I'm just going to draw a line here because it's going to be a little bit different. I'm going to put a coefficient in the front. Okay, so I'm going to put this, and then I'm going to go 8x, and then, I don't know, 11. Right? When there's a coefficient in the front, what we do is we factor out this coefficient. We factor it out of the first two terms. Okay, I've factored it out of the first two terms. Doesn't matter what the coefficient is, it does not need to be a common factor, but whatever the number is, we put it on the outside so that the inside begins with x squared, so that it's a simple trinomial on the inside. And now this is negative 2, and now I'm going to work with the inside. I have x squared minus 4x, and I'm going to add something that's going to create a perfect square trinomial. So how did we do it in the other questions? We took this number, we divided it by 2, and then we squared it. Right? That's what we did with all the other ones. So that number that I'm going to add, negative 4 divided by 2 is negative 2. Square of that is a 4. So it's going to be adding a fake 4. You can't just add a 4. You got to subtract it again. That would be like adding 0. This part over here is x minus 2 squared. Okay, and you can check that by expanding it. You should get that as well. But where did I get the minus 2? That's just this. That's the stuff inside the bracket. That's just minus 2. So it's half of the middle term. is going to be in your factor, okay? And then that half of the middle term squared is going to be the fake number that you add. Now, I'm going to split the inside of the bracket into parts. So the first part is x minus 2 all squared. The second part is the -4, but remember, the -4 is in a bracket that's multiplied by -2. So essentially, I am distributing this -2 to the trinomial, and I'm also distributing it to the -4. And then I have my plus 11 from before, and that's -2 times x minus 2 squared plus 8 plus 11, which is y equals -2 x minus 2 squared plus 19. And so the vertex is 219. Okay, so you'll need lots of practice with this because often you get fractions. Okay, so if I, for example, had y equals -2x squared plus 9x plus 11, then when I factor out my -2 from the first two terms, I'm going to have to divide each of these terms by -2, and that's going to give me -9 over 2x plus 11. Okay, sorry, I put the bracket in the wrong place. Let me just fix that. Okay, and so this is a little bit harder now because if I want to calculate what the fake number is that I'm going to add to this to make a perfect square trinomial, I'm going to introduce more fractions. So I'm going to add a fake number and subtract it away again. So once again, how do we get it? We go take the middle term, okay, and you got it divided in half. So it's divided by 2, divided in half, so divided by 2, which is, and then square it. That is -9 over 4, right? You'll go -9 over 2 times the reciprocal, so times 1/2. That's -9 over 4 squared, and you get 81 over 16. So fractions are really important here. They can get messy. So this is 81 over 16. Got to subtract 81 over 16, and so on. So you can see the numbers getting very, very messy here. X squared minus 9 over 2 plus 81 over 16 minus 2 times -81 over 16, right? We're distributing this 2 to this part and to this part. Plus 11. Wow, I picked some good numbers there, didn't I? Sorry, there's an X missing here and here. And now this inside here is going to be x minus 9 over 4. Okay, so what goes in the bracket is this thing that's being squared, right? Squared. And then this -2 times the fraction, I can actually reduce the fraction a little bit. And the two negatives will multiply to a positive number, 81 over 8. And I got to add that to 11. So I'm going to make the 11 also over 8. Common denominator. Woo, this is a workout. And so now I have a messier one, 169 over 8. So the vertex is full of fractions, 9 over 4, 169 over 8. Okay, so you're going to get all kinds. The process is exactly the same. And then after this, we will do applications of completing the square, which is given a word problem where an equation is given to you in standard form. You know, find the maximum or minimum value of something, which means you're going to have to convert it to vertex form, which means you'll be completing the square. All right, please practice a lot. Thanks for watching.